Know that force is a vector quantity, so it has both magnitude as well as direction. So we have to write Coulomb's law in vector form. In this form we have to write the magnitude of Coulomb force as well as its direction. So Coulomb's law in vector form, first condition is when position vectors of 2 point charges are given. Suppose 2 point charges whose position vectors are given. Suppose this is x-axis, y-axis, a charge q1 whose position vector is r1 and another charge particle q2 whose position vector is r2, and we have to find Coulomb's law in vector form, that is force with direction. Now you know that the two charge particles are like charges, they repel each other. Q1 exert a force on Q2 along this direction, and this force is F21. It means F21 means force on Q2 due to Q1. Similarly, Q2 also exerts a force on Q1 and its direction is along this direction, and this force is F12. F12 means force on Q1 due to Q2, and this is the distance between 2 point charges. Suppose we have to find F12. F12, its magnitude as well as direction. Consider a vector R12. This vector is suppose R12 vector, and its direction is from Q2 to Q1. Consider R12 vector whose direction is from Q2 to Q1. We can also find a unit vector along R12 vector. A unit vector along R12 vector is equal to R12 vector divided by its magnitude of R12 vector. This is a unit vector whose direction is along R12 vector, and this is the direction of F12. So we have the direction of F12 which is along this direction. We can also find R12 vector by applying triangle law of vector addition. Applying triangle law of vector addition, we have here R2 vector plus R12 vector is equal to R1 vector according to triangle law. So we can write R2 vector plus R12 vector is equal to R1 vector. This implies R12 vector is equal to R1 vector minus R2 vector. Please note that the direction of R12 vector is from Q2 to Q1. In my notation, its direction is from Q2 to Q1 and its value is R12 vector is equal to R1 vector minus R2 vector. Now we have both the direction of F12 vector and magnitude, so just write its magnitude and direction. Now we can write Coulomb's law in vector form as F12 vector is equal to 1 by 4 pi epsilon naught, first its magnitude Q1 Q2 by R square. This is the magnitude of this force, and now you have to write its direction. The direction of F12 vector is along R12 vector. The unit vector along R12 vector is this, so we can write this unit vector, but here R is the distance between these 2 point charges, so R must be equal to the magnitude of R12 vector. So we have to write mod R12 vector square, and unit vectors along R12 vector is R12 vector divided by mod R12 vector. This can also be written as 1 by 4 pi epsilon naught Q1 Q2 by mod R12 vector whole cube into R12 vector. You can also write the value of R12 vector from here, so it can also be written as 1 by 4 pi epsilon naught Q1 Q2 by R1 minus R2 vector mod cube into R1 vector minus R2 vector. This is the general form of Coulomb's law in vector form. Remember, this is vector quantity. It has magnitude and direction both. So when you use this formula, you must write the sign of these two charges, positive or negative charge. Thus, we can write Coulomb's law in vector form when position vector of 2 point charges are given. Q1 and Q2 are separated by some distance r, and you have to write Coulomb's law in vector form. In this case, Q1 exert a force on Q2 along this direction, and this force is called F21 vector, and Q2 also exert a force on Q1 along this direction, and this force is called F12 vector. Suppose you have to write the value of F21 vector. F21 vector in vector form, you have to write the magnitude of force and its direction. So the magnitude of force will be 1 by 4 pi epsilon naught q1 q2 by r square, and its direction, suppose this is x-axis, the direction of F21 is along positive x direction, and we have a unit vector along positive direction called I cap. So direction is given by I cap. This is also Coulomb's law in vector form, the magnitude and direction of force. Two identical balls each of mass m carrying identical charge and suspended by two threads of equal length from same point. At equilibrium, distance between them is r, and the threads makes an angle 2 theta with each other. Find the charge on either ball. When two balls carrying identical charge are suspended from identical threads, they must repel each other like this. The separation between them is given r. Suppose the two balls has charge q on each, and the angle between the threads is 2 theta. Since it is angle bisector, so both angles are equal to theta, and mass of the ball is m. In equilibrium, suppose this is a system, we have to represent all the forces acting on this particle. Since it has mass, so it will experience a gravitational force which is equal to mg along vertically downward direction. These two charges repel each other. This charge exerts a force on this charge along this direction, and this force is Coulomb force, which is equal to K q1 q2 by r square. Here q1 and q2 both are same, so we can write q square by r square. And the ball is suspended by a thread, so there is a tension along this direction. Now resolve T in this direction. This is theta, this is also equal to theta, this is T cos theta, and t sin theta. In but horizontal direction, t sin theta is equal to k q square by r square, and t cos theta is equal to mg. Solving these two equations, we get tan theta is equal to k q square by r square mg, and from here q square is equal to r square mg tan theta divided by k, and q is equal to under root r square mg tan theta divided by k. Thus, the charge on each ball will be equal to this.